you'll notice that since we got a fraction on this one, we're going to have to use quotient rule. There is no way around using quotient rule here. There's no way we could break it up to avoid it. And so for quotient rule, you could go ahead and check your notes if you don't remember it. Hopefully you do remember it. So we start by doing low d high. So that's going to be x minus 5 times the derivative of the top. Now what is the derivative of 3?
0.
0, absolutely.
Oh.
Then it's minus high d low. And the derivative of x minus 5 is just 1. And that's all over the square of what's below. So we take the x minus 5 that's on the bottom and we square it. Now notice if we simplify the top of this one, a lot of stuff simplifies because, of course, the 0 times x minus 5, that whole chunk just ends up being 0. So all we're left with on the top is just a negative 3. And on the bottom, it's either x minus 5 squared, or if we expand that out, x squared minus 10x plus 25.
Which size is it?
So yesterday, we did a lot of work with the quotient rule just with polynomials. Today, we get to start throwing in some of the other function types we know, like the natural exponential. So go ahead and find this derivative, please. So this is what we get when we actually just use quotient rule and just plug everything in. Now, this can be simplified a decent amount, though, because on the top, if we actually distribute in those e to the x's and stuff like that, we have e to the x minus e to the x squared. But how do we do e to the x squared? There's a shorter way to write that.
E to the 2x.
Yep. Remember when you have a power to a power, you multiply the exponents? So e to the x squared is the same as e to the power of 2x. And then that's going to be minus a negative, okay, so that's going to become a plus, e to the x times e to the x, so that's again another e to the x squared. So that's going to be another e to the 2x. Now I'm going to go ahead and leave the bottom just as it is. I'm going to go ahead and leave it as 1 minus e to the x squared, at least for the time being. If you want to expand it out, you can. But notice what we can do now. On the top, that negative e to the 2x and the plus e to the 2x cancel each other out, so we're just left with e to the x on top. All over 1 minus e to the x squared. And that's good for our final answer. And again, if you want to expand out the bottom, you can, but you don't need to. One thing to look out for is, how do you know when you do and don't need to simplify? Well, really it comes to thinking it through. When you take a look at the top especially, kind of look ahead before you actually do the math. And usually what you'll see is that there's going to be some like terms that you can combine. If there are, do so. So like in this case, I knew that I'd end up doing the e to the x times e to the x there, and I'd do it here. So I knew something would combine. So that's how I knew to go ahead and try to simplify. All right, next problem. Let's throw some trig in there. Please find the derivative of this function. So when we just use quotient rule and just plug everything in, this is what we're looking at. Now, you can do a little bit of cleanup there on the top, but there's actually not going to be much we can do in this particular case. Because on the top, we can just make this first part into just x times cosine of x. And for the last part, well, sine of x times 1 is just going to be sine of x, so that's going to just be minus sine of x. And yeah, it's all just over x squared. There's nothing else we can do here. There's no particular like trig identities or anything that we can all of a sudden plug in at this point. So we're done. This is all you can do at this point. So now that you've taken derivatives using quotient rule, now let's actually use it for a purpose. I'd like you to please find the equation of the tangent line at this given point for this equation, please. So to start with on this one, if we're going to find the equation of the tangent line, the first thing we do is we find the slope of the tangent line, which means derivative. So first up is I'm going to figure out what does y prime equal. So we got to use quotient rule on this one because there's not a way to get around the e to the x over x. Well, you could try to use product rule by turning an index to the -1, but we don't want to. And so go ahead and use the quotient rule here. So low d high, so x e to the x, minus high d low, so that's going to be e to the power of x times the derivative of x, which is just 1, all over the square of what's below, so that's all over x squared. We clean it up a little bit potentially. We could turn this into x e to the x minus just e to the x over x squared. But that's about all we could do. I mean, we could factor an e to the x out of the top, a few things like that, but nothing much is going to go on. All right, but now that I've found the derivative function, I still need to find the slope. In order to find the slope, we now need to actually use the point that we are given. So I'm going to plug that into my derivative. Now notice that when I do that, I don't need to use both of those parts, because my derivative function only includes x. So I'm just going to plug that value of 1 in for x in my derivative equation. All right, so we plug 1 into the equation.
Wait, what?
And that ends up giving us just e to the 1 minus e to the 1 on the top. So that's e minus e, which is 0. So you got 0 over 1. Of course, 0 divided by 1 is just 0. So our slope is 0. But we still can have an equation here for our line. So to find our line, then, it's going to be y equals, well, 0x. Well, that's just 0. Plus the y-intercept. What would the y-intercept be then for this? Well, it must be my y-coordinate. So in this case, the equation is y equals e. And you're done. So first step, we got to find our derivative function. So there's our work using quotient rule and the derivative function. Once we've done that, now we need to find out what the slope is of our tangent line, which means plug in your x value from our point in for x in our derivative. So we go through, we find out what the slope of our tangent line is, and this one gives us 0 again. But our answer here is not going to be that our equation is y equals 1. Because you'll notice this one's normal line. Well, got to think about what this means then. We got to kind of think it through, because if our slope of our tangent line is 0, that means it's horizontal at that point. Well, we want the normal line. And we can't exactly do opposite reciprocal of 0, right? Because we can't flip it. So then, how do you write the equation of that? Well, the normal line is perpendicular, so that means it must be vertical, right? How do you write the equation of a vertical line that's passing through the point 1, 1? Well, a vertical line, yep, is always x equals. And what is the x coordinate that it must equal? So there's our equation. X equals 1.